reactions. These are substitution reactions that are nucleophilic that follow first order kinetics, which means that simply the rate law is just dependent upon the concentration of K times the alkyl halide. Right now, these have a couple steps. The first step, you form a carbocation intermediate, and then the nucleophile attacks really fast. So that will be your fast step. Right now, these usually favor weak nucleophiles. So you'll see stuff like H2O, methanol, you might see ethanol, and stuff like that. And weak nucleophiles are stuff that are not charged, right? They're just there. So you notice that no charge is associated with any of these nucleophile or bases, right? Now, these typically favor polar protic solvents. So these same stuff that are acting as nucleophile may act as solvents also, all right? One more important thing, well, two more, is that they show no stereochemistry if and only if there's no chiral center present. If there's a chiral center present in the molecule, Sn1 reactions will show a 50-50% mixture of two enantiomers. So that is very important. You may lose some points on an exam without knowing that. All right. So that being said, let's look at a couple examples. So suppose we let's look at this one. Suppose we're given a molecule like this. All right, and we add water. What is going to happen? Right. Well, the first thing in Sn1 reactions, and this is going to go through Sn1 because we have a weak nucleophile, but we have a tertiary alkyl halide, which means that this is very crowded. So this weak nucleophile could never attack just right on in one step, which we're talking about Sn2. That will never be an Sn2. This will be an Sn1. And here's the mechanism. The bromine pops off because it's too not accessible. The bromine pops off first, and we get something that looks like this. We have a plus charge here. Now notice I went from stereochemistry showing no stereochemistry, and the reason behind this is that this carbocation here has a trigonal planar geometry, which means that planar implies that it's flat, so therefore no stereochemistry can be shown here. All right, so we have this carbocation intermediate. Right now, this leaves our water to attack as a nucleophile. Now that it's less crowded, the water comes in, attack this carbocation, and we get something that looks like this. CH3, and this is bonded to an O that is bonded to two H's. Now be careful here. Be careful of your pharma charges here. Oxygen with three bonds, always give you a +1 formal charge. And then simply to get our neutral product, another pair of water molecule comes in, acts as a base, takes off these hydrogen, kicks off the bond on the oxygen to give you your formal neutral molecule, which looks something like this. You form an alcohol. All right, so this will be a product. Now, because we have a chiral center present in the molecule, showing stereochemistry, we'll get something like this. And then I'm going to add a plus enantiomer, and this will be the products. These will be the products we'll see. And all this is just changing the enantiomer. Just says the other enantiomer just says changing your chiral, your wedge and your dashes. All right. So let's look at another one. What if we were given this? Sn1 reactions, right? And we add something like ethanol to it. Now notice how my substrate is weak. I have a secondary alkyl halide, which implies that I have one hydrogen right there, but I have a weak substrate. So even though it's slightly open in terms of secondary, this nucleophile is weak, and so it could never do Sn2, right? So the first thing is going to happen is that this bromine is going to pop off and leave, right? We get the molecule looks something like this. we have a plus charge in that carbon here, right? Now notice something, right? I have a secondary carbocation here. So here's something that weird that happens. Here you're gonna have a 1,2 hydride shift. This is called a 1,2 hydride shift. And what is gonna happen is that these, because it's more stable to do Sn1 chemistry on a tertiary alkyl halide, on a tertiary carbocation, the hydrogen that is here is going to come down and satisfy this plus charge. And now we're going to have something that looks like this. Now the plus charge is going to be on that tertiary carbocation, which is much more stable than what was here. And this is our intermediate. I always put our intermediate in brackets, right? That is intermediate that will form. Now on the other step of the reaction, another molecule of ethanol, CH3, CH2, OH, with these 2 lone pairs on the 4 lone pairs, comes in, all right, attacks the carbocation, all right, and now we get something that looks like this. All right, we have an O bonded to a H and a CH2, CH3 with a plus charge. Be careful of formal charges, right? And then simply another mutual molecule of ethanol, CH3, CH2, OH, comes in, act as a base, take this hydrogen, right? Takes this hydrogen and then kick these electrons on the oxygen, and we get a neutral product to be something like this. OCH2, CH3, and we form an ether. Now notice that this does not give us a 50-50 mixture of enantiomers because there's no chiral center present in the molecule. Let's look at another example. All right, what if we were given something like this? You add CH3OH. What will be the products? What will be a product? All right. Well, this is Sn1 chemistry again. You have a secondary alkyl halide, but a weak nucleophile. And so the first thing that's going to happen is electrons are going to pop off in the chlorine, and you get something like this. All right, you get a form of +1 charge here. Yes. Now be careful. There's no rearrangement that could happen here, right? There's no rearrangement. We already have a secondary alkyl halide there, secondary carbocation. So there's no rearrangement that could happen. So again, these electrons of the oxygen comes on bond, and we get something that looks like this. Bonded to an O with a CH3. Right, oxygen with 3 bonds +1 formal charge, and then simply another molecule of methanol comes in, acts as a base, plucks out the hydrogen, these electrons kicks off on the oxygen, and you get a neutral product, be something like this. And you also get an ether right here. All right, how about this one? And guys, for the purpose of this video, I know there are actually more products that form, but we only care about the major product in this sense, right? So what if we're given this compound and we add CH3, we add the same methanol to it? What would happen? Right? Well, notice there are chiral centers here, right? We have a carbon that's bonded to a chlorine, a hydrogen, this R group over here, and a different R group over here. So this is chiral, and so is this. So we're gonna get a 50% of enantiomers here. Now, remember, we have a weak nucleophile on a secondary alkyl halide. So you kind of see the pattern here. The nucleophile is not charged or strong enough to just attack and give us a substitute Sn2 reaction. So the chlorine has to leave first. So the first thing that happens, these electrons pop off on the chlorine, right? And we get something that looks like this. We have a plus charge here with this CH3 here, right? Now we have a secondary carbocation, You have a secondary carbocation, right? But look what happens. We could do a 1,2 hydride shift here, rearrangement, and our intermediate will look something like this, with a plus charge here. Now notice how I went from stereochemistry to no stereochemistry. Went from this to a trigonal planar system. Planar implies being flat, so no stereochemistry has to be shown. No stereochemistry could be shown. And again, anytime you have, anytime you could do a rearrangement, anytime you see that there's a possibility of forming a tertiary carbocation instead of a secondary or primary, you could do it, but you could only do it with hydrogens and methyls, right? So now we have an intermediate that looks like this. So all that happens is that another molecule of methanol comes in. Now that this is fairly open enough, it comes in, attacks the carbon, attacks the carbon with the positive charge, and we get something that looks like this. CH3 with an O bonded to an H and a CH3, right? Anytime oxygen has 3 bonds, that's just a +1 formal charge. And then last step of the reaction, another molecule of methanol comes in, acts as a base, leaves that hydrogen, these electrons kicks off on the oxygen. We get something that looks like this. CH3 with an ether. Well, put it in the wrong place. There should be an OCH3. So we get something that looks like this. But because there's chiral center present in the molecule, we have to show stereochemistry. And so really what we get is something that looks like this. You could have your CH3 going away and then your OCH3 coming out at you, and this will be, and the other enantiomer. So this will be the products you will get. You get a 50-50 mixture of 2 enantiomers because there's chiral centers present in the molecule to begin with. Let's look at another one. What will happen to this molecule? Well, this is a typical Sn1 reaction again. You have a weak nucleophile on a fairly, not that crowded, but it's crowded. It's not as open as a primary alkyl halide, right? It's not as open as a primary alkyl halide, but because this is weak, this bromine has to leave first. So the electrons kicks off on the bromine, and you get something that looks like this. You have a plus charge here, you have 2 methyl here. But here's what happened. You also get a 1,2 methyl shift here. Rearrangement that will give you an intermediate, and all that happens is that one of these methyl groups comes down and shifts to satisfy that plus charge to get your plus charge on a tertiary carbocation, right? So now you get something that looks something like this. You get a methyl group here, we get the other methyl group here, but a plus charge here, and this is much more stable than having your plus charge here. Right. So all that happens is another molecule of ethanol comes in. It's now favorable to attack the carbon, and we get something that looks like this. We have an O bonded to an H, and this is bonded to a CH2, CH3, oxygen with plus charge, because it has 3 bonds. And then on the last step of the reaction, a molecule of ethanol comes in, acts as a base, gets these hydrogens, these electrons kicks off on the oxygen, and you get your neutral product to be something like this. OCH2, CH3, and you form an ether. No stereochemistry shown because there is no chiral center present to begin with. So be careful. Look for rearrangements. Whenever you could rearrange with methyl and hydrogens, look for it.